Hi everyone, Engineer Liu here. So on the last video we started talking about string manipulation in C, and we explored some functions such as string copy and string concatenation. But really the best way to understand string manipulation in C is to actually write the functions ourselves. Now that we know how to write functions in C, how to work with pointers, we can start writing. We can write actually our whole string library in C. So let's get hands-on on that, and hopefully things will get a lot clearer. So we go only with standard IO and our main function. And the first function we need to have in our library is a function to compute the string length, right? So string length returns long unsigned int, which in C is called size t, and we'll call it simply string length, and it takes a char, which will be our string, okay, which will compute the string length. And how do we know that a string, the end of a string in C? Well, all strings in C, they have no character at its end, so it's given by this, right? So what we can do is the following. We create a variable side int I, an auxiliary variable, equals to 0, right? And while actually we have to use a long unsigned long int, and or simply size t, right? While string of I is different than the null terminating character, right? Then we increase our counter, okay, or auxiliary variable. And at the end, if it encounters the null terminating character, it returns, let's say, or let's call this or my string length. Okay, we're gonna compare it with the real string length afterwards. So in the end, it would encounter the null terminating character, and then it would simply return I. Okay. So this is what basically the string length function does. And let's include here string.h, and we'll test it with char string1 equal to test, which will be, we expect a string length of 5 characters, 5 bytes. And we print here string length. Remember, this is long inside int, and we use first our string length, and then my string length, and then the string length itself gives also our unsigned int. And here we go. And we compile. We have some issues here. String length, string. Implicit declaration of function my. Okay. here is actually warning, my string length. While, oh yeah, we forgot the curly brackets over here. Now we have everything runs fine, and there we go. We got the same result as expected. Okay. So now that we have a string length, we can write a function to concatenate two strings, right? So let's try that. We call it a void because we'll be referencing both strings. So let's call it my string cat. Let's call string destination string source, and we're gonna try to make it safer than the original string, right? So if my string length of source is actually, we need to check how many bytes we have available here. So it will be wise to include a size t argument here, n. So if string length of source plus my string length of destination is greater than n, then we can call it int, and then we return -1 to indicate that we obtain an error. Otherwise, we can then concatenate our strings, right? And we can do it the following. So while a string has declare an auxiliary variable size ti equals 0, and we do pretty much the same while string is different than no character. We need to know which point it ends, okay? And then we increment. Why it's different? So it will be equal to the non-terminated character. Then we stop, and then we need to start copying character by character, right, into actually our destination, right? So here we call destination and source. So typically size n will be the size available for in the destination. It won't be the string length itself, it's the size available. So now yeah, while we set yeah, we can use a, let me think, a second, I guess, size tj for the other string. So while source of j is different than the null terminating character, we assign dst y plus j equals to source j. Okay, I guess that's it. And then we increment j. Yeah. So this condition here will make sure that we don't write in memory we don't have available. Okay, so and then everything runs fine and everything returns 0 to indicate that all went good. So here actually we need a 10 and we're gonna concatenate with string 2, which is only 5. So here we have the null terminating character, and then it will be overwritten by this one. So now we can test it. My stringcat string 1, string 2, and the size of the buffer, which is 10. And then we can print our string string 1 like so. We compile, no problems, and yeah, it didn't work. Let's figure out why. So here we went to the end of the string destination, and then the following j I plus j will be equal to source j, and then we advance, and that should get us yeah, so let me check here. If is equal to 0, then unless we do nothing, unless we obtain an error, yeah, definitely obtain an error. So an error occurred. No. Yeah. So basically, when we pass this argument here, we have 10, which needs to be equal. String length of source plus string length of destination must be equal to. Must be greater. Actually, it must be equal or greater than n. So I guess that will work. And I always mix up the order here, and I guess an error occurs. So we have 10, 5 plus 5, 10, and that should be enough. So we have 5 plus 5, string length of string 1, it's 5 and 5. Let me check string2, it should give the same result. So string2 is giving us a length of 10, which really doesn't make sense. Let me check here. So we got 10 and string length of 10 for string 2. Yeah, so for some reason string length is giving us a length of 10 for this one. And yes, I think I know what the problem is here. We are forgetting about the null terminating character. Yeah. So that's it. So always remember, in C we have to make room for the null terminating character. So yeah, unless it will break. Okay, so actually here now we have 11, and let's make it all string 2 here. Yeah, so it worked properly. So as you can see here, when we try to compute the string length for a string we initialize without room for the null terminating character at the end, which was this case of test2, in case we have here 1, 2, 3, 4, 5 characters for 5 bytes, and we didn't leave room for the null terminating character, so we have undefined behavior here, and that's why we obtain 10. When we ran my string length, it keep reading in the memory in regions it wasn't supposed to read in the memory until it found the null terminating character, and whatever string was written there, we don't know really, because we shouldn't be looking there. So yeah, that could be very dangerous. So yeah, always check if the strings you're working with terminates with they terminate with the null terminating character. What we can do is on my stringcat we can check for other errors. If destination string length, which would be 5 plus 1. So if string length of destination plus 1 is different than null terminating character, we return -1, and also we check if source of string length source plus 1 is different than and null terminating character. We also return, actually here we can use different error type codes like -2, -3, and then map them in another moment, but let's say if we obtain a return value of below 0, it means error in general, so we can do that, else yeah, an error occurred, and then we can handle each type of error differently. And yeah, let's check that. An error occurred. Okay, so what's the issue here? Let's string length. Yeah, here we actually don't need +1, and here also +1. Yeah. Actually, here, let me check. Yeah, it worked. Let's say here instead of 6 we had 5, which was giving our error, remember? Yeah, so we prevent that error of not having the null terminating character properly, and yeah. So for sanity check, let's check the last character of string 1, last char of string 1, which should be the null character, indicating that we have we won't have undefined behavior if we work with that string in the future. Okay, so it will be string 1 and 11, and oops, let's yeah, it should be, we don't see anything here because it's no character, so it doesn't show up. So what we can do is test it like this. If string 11 is equal to new terminating character, then yeah, we got last char of string 1 is the null char, and that's it. Actually, here it's string 1. Yeah, just let's add the new line over here, and that's pretty much it. Yeah, the last char of string 1 is the null char for this case here. So what we end up doing in this video is we could say a more robust and less prone to error version of stringcat, because we verify if both strings that we are concatenating both ends with the new character. So since we use string length a lot, we avoid any sort of undefined behavior. Okay, and well, since we are using string length here, we also are prone to errors of that type, but here also we check if we could have some form of buffer overflow, and return -3 here. And also, well, there we implement our logic. We find out where the destination string ends, and then from there we concatenate char by char on our source string, and then finally we got the two strings concatenated, right? So the big lesson here regarding strings is that strings in C are tricky. They are very dangerous. You can easily make your program, your software, prone to vulnerabilities. So you have to be very careful with strings, and if possible, use libraries which have more robust implementation. So with that all details in mind, I hope you I hope you that is watching this video got a valuable lesson regarding safety of C programs. Right, so before this video getting too long, I'll end up here. So hope you guys enjoyed. See you next time. Don't forget to like, subscribe, and comment. And bye.